Okay, so well, just first off, let me let you know I left the original packet at school. So I'm just basing the problems off of the answers. So some of them may not match exactly, but the concept is the same. Okay? So don't get, don't stress about like, oh, it's not exactly the same problem or the same variables, but the concept is the same. So if this were the problem for 18, they're asking for the angle that makes this statement true. Remember, anytime you see inverse, they're talking about an angle. So cotangent is negative in quadrant 2 or quadrant 4. Because it's the inverse function, you know that it has to be in quadrant 4. So the angle associated with a ratio of negative radical 3 is, and if you want, you could draw it. So it would be in this quadrant, and we know that cotangent is x over y, so it would be radical 3 right here, and negative, I know it looks like a 5, but it's a 3. And a negative 1 down there to make it a negative radical 3. So this angle would have the coordinates radical 3 over 2, negative 1/2. And how do I know that? Because of this being the x and this being the y. So notice how in the first coordinate x is radical 3, and then in the numerator, and then y is negative 1 in the numerator. So this angle here is a 30-degree angle. But because it's a cotangent inverse function, you can't just say it's a 30-degree angle or a 330-degree angle. You have to go in the negative direction. So you either say negative 30 or you say negative pi over 6. Okay, so that would be the answer right there. So sine inverse of 1/2, the ratio is positive 1/2. So the angle associated with a sine of 1/2 is a 30-degree angle. So you either write 30 degrees or you write pi over 6. And then the next one is 36. And that one is sine theta equals negative. So this one you need a calculator, and it has to be in radian mode. And how you know that is because it says that the interval is between 0 and 2 pi. So you have to be in radian. Sine is negative in quadrants 3 and 4. Now the angles that you're looking for are this one and this one. The red and the green are your two answers. Now the calculator is going to give you this angle right here. It's going to give it to you in negative radians. Okay? So the easiest angle to get right away is the green one. So you're going to do inverse sine of negative 0.56 equals, and that's going to give you the black angle. Okay, that's not the answer you're looking for. You want the green angle. So in order to get the green angle, to get the green, you're going to take whatever the calculator gave you, the black angle, plus 2 pi. Okay? And then to get the red angle, well, remember that this one, the one the calculator gave you, and this angle right here that I'm marking are congruent. They're the same measure, so they have the same radian measure. So in order to get the red angle, which is your second answer, you're going to take the absolute value of the black angle, absolute value, and add pi to it. Because if you know this measurement right here and you add pi, which would be, I'm using black here, that would make your red angle. Okay, so that's how you get the answer for that one. For cosine theta is negative 0.92. Well, cosine is negative here and here. So you want this angle, and then you want this angle. Now the calculator is programmed to give you the red angle directly. So all you do is inverse cosine of negative 0.92 equals. And that's going to give you the red angle, which is the first answer you need. To get the green angle, the red angle measures the same as this one that I'm marking in black. So all you need to do to get the green angle is take 2 pi minus the red angle, the one on your calculator screen. And there you'll have both answers. For number 38, you're solving sine 2x equals sine x. You're solving for all values of x and make this true in the interval 0 to 2 pi. The first thing I would do is make one side equal to 0. So I'm going to move the sine x to the left. And then since I cannot combine sine 2x with sine x, I'm going to change this one using the double angle or the multiple angle formula to 2 sine x cosine x. And notice how they have sine in common, so I'm going to factor that out. And so now I said each one equal to 0, each factor. The first factor, the cosine x minus 1. So for the second one, I know that cosine x is 1/2. So I'm going to solve for x. For the first equation, sine x equals 0, I know that that is true when x is 0 and when x is pi. For the next equation, cosine x is 1/2, I know this is true when x is pi over 3 and x is 5 pi over 3. And here are the 4 answers for that one. Okay, so this is another one where I'm not sure what the original problem says. It may be U and V instead of A and B, but it's the same thing. Also, I don't know if they tell you directly that the angles are in quadrants 2 and 1, or if they give you intervals. But either way, this is what you end up with. A is in quadrant 2, B is in quadrant 1. So the first thing I do is I go ahead and I sketch the angle. So for angle A, quadrant 2, so this would be for angle A. Cosine A is negative 513, so that's x over r. So then this makes this a 5, 12, 13 triangle. And then for angle B, I'll just put the B up here because it'd be too crowded inside the angle there. Sine of B is 15 over 17, so that's y over r. So that makes x equal 8. Now how do I know that? Pythagorean theorem. So just a squared plus b squared is c squared. Now they're asking for sine of a minus b. So that's sine a cosine b minus cosine a sine b. I'm just going to go to the triangles or the angles and pick out the ratio. So sine a, I go to angle A, and that's 12 over 13. And then cosine B, go to angle B, that would be 8 over 17. Whoops, 17. Minus cosine A, that would be negative 5 over 13. And then sine B, 15 over 17. And then just take your calculator if you'd like. Don't forget, a negative times a negative right here is a positive. And so you're going to take 96 plus 75 over whatever you get from 13 times 17, and then simplify. Number 27 is sine inverse 1/2. So this one is very straightforward. The angle is either 30 degrees or pi over 6. Again, if you know your unit circle, this is a piece of cake. If you still haven't learned your unit circle, you're going to struggle and it's not going to make any sense. So, because this is asking what angle gives you a sine ratio of 1/2. And it's an automatic answer. It's 30 degrees or pi over 6. Now you might say to yourself, well, sine is positive here and here. Why is there only one answer? The reason is because it's the inverse function. And for inverse function, there is only one answer. And if it's a positive ratio, it's going to be the one in quadrant 1. So that's why it's 30 or pi over 6. For number 29, it's identical to 24 in the methods and in the strategy to solve and the formulas, everything. The only thing obviously is that the answers are, the angles have different ratios, but once you use Pythagorean theorem to solve the missing piece, this is what you get, what you see on the screen. So I solved for the third side by using Pythagorean theorem. Okay, so it's the same ratio, sine A minus B, just like 24, exactly the same actually. So this is going to be sine A cosine B minus cosine A sine B. So the numbers will be 2 radical 2 over 3. Cosine B is 1 over radical 5. Cosine A would be 1/3. Sine B is 2 over radical 5. When you simplify this, you get 2 radical 2 minus 2 all over 3 radical 5. Oops, 5. You're going to rationalize because you don't want a radical in the denominator. And this is what you get. And then, put up a little bit. Distribute the radical 5 in the numerator. So that gives you 2 radical 10 minus 2 radical 5 all over, when you multiply the radical 5 with the radical 5, it's 5, and then there's a 3 there, so that is a total of 15. So there's the answer right there for 29. Now for number 39, you have to use the law of cosines based on what information they gave you, right, about the triangle. So this is a formula. Minus 2ab cosine c. Okay, so they told you that the side was 52, the other side was 71. So 52, 71, and the angle between them was 50 degrees. So for this problem, you have to make sure your calculator is in degree mode. If you're not careful about that, all your answers are going to be wrong if you're in the wrong mode. Okay, so just remember that. Check before each problem. Make sure you're in the right mode. And then your calculator takes care of the rest. I mean, I'm not going to do these by hand because 52 times 52, the calculator will do it in seconds. So just plug it in exactly like you see it. 52 squared plus 71 squared minus 2 times 52 times 71 times cosine 50. Now that's going to give you c squared. You want c. So you have to take the square root of the answer that's on your calculator, and then that's going to give you the answer you're looking for, which is c. Okay, and that's it.